Hello class, we're continuing the previous learning intention, and in this one we will learn how negative indices interact with other index laws. Just so that we know what we're talking about, I'll show you the index laws again in a few examples. So if we have two things with the same base multiplying, so if we have a to the power of m times a to the power of n, that becomes a to the power of m plus n, like that. And then the other index law that we know, I hope you remember, is a to the power of m divided by a to the power of n becomes a to the power of m minus n. And finally, the other index law that we have is if we have a fraction, or pretty much anything really, this is the distributive law. If you have a to the power of m, okay, a to the power of m times, or outside of n, that becomes a to the power of m times n. And finally, if we have, this time it's a little bit different. We have a over b, two numbers, to the power of n, that becomes a to the power of n over b to the power of n. These are the laws that we are going to apply with negative indices. And just so that we have a few examples to start off with, let's begin with an example for this one. So if we have, let's say, x to the power of 5 times x to the power of 3. Can't see that in the camera. Let me fix that up. 3. That becomes, that's equal to x to the power of 5 plus 3, which is 8. And this one, if we have, just as an example, if we have t to the power of 7 divided by t to the power of 4, that is equal to t to the power of 7 minus 4, which is 3. If we have, just for example, doesn't really matter what letter we have, we'll pick b to the power of 2 outside to the raise, I don't know, 5. That becomes b 2 times 5, which is b to the power of 10. And finally, just as an example, this is getting a little bit messy, we'll make it x over y to the power of 4. That will become x to the power of 4 over y to the power of 4. So now we're going to do the exact same things with here, except we're going to see what happens if we apply negative indices to them. So let's take for example this one, example 1. Let's say we have x to the power of 5 times x to the power of negative 3, x to the power of, so it's just kind of like this. Well, since it's multiplication, we'll treat it like this first one. We're going to add the indices, but we're going to keep them as they are. So for example, by that I mean this is going to be x to the power of 5 but we're going to add a -3. Let's think of that for a moment. 5 plus -3. Well, really, 5 plus -3, that's x, that's 5 minus 3, which is x squared. So as you can see that even if they're negative, they still add. Okay, and we'll do another example. We'll go straight to the more complicated one now. We have 3a to the 7 times 4a to the power of -4. That becomes, well, we do the numbers first. 3 times 4, that gives us 12. Then we applied the index laws for these a's because they have the same base. So it's going to be a 7 plus -4, which will give us 12a, well, 7 plus -4, which is just 7 take away 4. 7 take away 4 is 3. That there is our answer. Now we'll do an example for this one here. Well, what happens if we have, instead of x, we'll pick a to the power of 5, because I like the number 5, divided by a to the power of -2. So what happens now? Well, we'll apply the exact same index law. This will become a to the power of 5. Since it's division, we're going to subtract. So it's going to be minus this indice. But that indice is -2, so it's going to be -2. And I hope you remember from last year's work in year 7, it's 5 minus -2, which really becomes 5 plus 2, which gives us a to the power of 7. Okay, now let's go straight to a much harder example. So we'll do 12b to the power of 7 divided by 3b to the power of -4. Same thing, or similar thing I mean. We do the numbers divided by the numbers. What is 12 divided by 3? 12 divided by 3 is 4. And again, b to the power of 7 minus, because it's division, -4, which is 4b. 7 plus 4 is just 11. Okay, we'll do another one. Now we'll do this example here. I hope you're beginning to see what would happen. Let's pick the example of a to the power of 3 outside the power of -4. Well, using this index law, we're going to apply it to this one. So it's going to be a to the power of 3 times -4, which will give us a to the power of 3 times -4 is -2. 12, which if you watch the previous video, it'll be 1 over a to the power of positive 12. Okay, going straight to a slightly harder example. So we'll go with 3a squared b cubed to the power of negative 2. I hope you remember. This 2, negative 2, distributes to every single one. So it's going to become 3 to the power of... 3 has a 1 there. There's a hidden 1 indice there. So 3 to the power of 1 times negative 2 becomes negative 2. A negative... 2 times, because it's in the brackets, negative 2 is negative 4. And B, 3 times negative 2 is negative 6. And since everything here is negative, it will become 1 over 3 to the power of 2 is 9. And everything else will stay the same. It will be a to the positive 4, b to the positive 6. One last example. Let's take a to the power of 4 over b to the power of 2 outside to the power of negative 2. Well, we know that if we have some indice like this outside a bracket and a fraction similar to this one, it distributes or multiplies to every single term inside the bracket. So this is going to become a to the power of 4 times negative 2. So let's go 4 times negative 2 over, same thing with the b, 2. Let me adjust the camera a little bit so it's centered. So this will become b2 times negative 2, which will give us a to the power of negative 8, because it's 4 times negative 2 is negative 8, and 2 times negative 2 is b times negative 4. Now here's where it gets tricky. Remember, we don't like negative indices, but that a to the power of negative 8 will move to the bottom. It's because negative indices go onto the denominator, and since this is already in the denominator, this will become the numerator. So they're going to swap because they both have negative. So it's going to become b to the power of 4 over a to the power of 8, and this stays as it is because they cannot subtract from each other, the indices I mean, because they have different bases. Okay, I hope that gives a good outline for the work that you're going to be doing today. Good luck.